As you might know already, functions allow us to store a procedure or a computational or logical block that can be reused. It's like a chef pre-making the broth that she can keep using in different dishes throughout the day without having to make it every time a recipe calls for it. Let's start by creating a function that can be reused. I'll be writing a function named square that takes a value and returns its square. Once again, I will be commenting my code. So you'll have to type function, then you put x, then you start your parenthesis, and you do something like this. So every time you call this function with a value of x, the function will return you x multiplied by x, which is a square. So you can write this code in a file and save it. I'm creating a new R script. I'm pasting it here. Save it inside lecture 8. I'll save it inside lecture 8. I'll call it a function square dot R. So now I have saved it. So if you run it, nothing will happen because our function is not supposed to produce any output. But now, if you go to the console and run a command like square 9 and press enter, you're seeing the answer as 81. So we just created a function called square and it's ready to be used anytime we need this kind of functionality. In fact, if you look at the environment on your upper right corner, you can see there's a function called square. So you know that this is the function which we have created. And this function is now available to us for the rest of our work. Next, we will come to importing data. This is the most useful part of R for data science. Almost none of our actual problem solving will work without first having some data available to us in R. So let's see how to import data into R. For now, we'll work with CSV data as we did with Python. R has a function which is called file.choose. This function allows us to pick a file from our computer and the read table function that reads the file as a table, which works great for CSV formatted data. For this example, I'll use the IQ data file, which is called iqsize.csv. Let's go back to our RStudio and type it. Even in R, I'll use df to show it's a data frame, and I'm using the read.table function. Inside it, I'll do a file.choose, and I put header equals to true, and separator is comma because our file is a comma separated file. So let's run this line. Now this opens up a file.chooser window. I'll go to lecture 8 and I'll pick the iqsize.csv file, and then I'm importing it as a data frame or as a table. On your right, you can see df says 38 observations of 4 variables, which means that there are a total of 38 instances or 38 rows, and 4 variables are the 4 columns. The name of the columns are PIQ, brain, height, and weight. So in our next line, we'll do brain equals to df brain, and so now brain with the small b is an array where we are taking one column from the data frame, and I'm printing the summary of this list or of this array brain. You can see this is the statistical summary which we printed in Python. This is the descriptive statistics here. So I know the minimum value, I know the first quartile, median, mean, third quartile, and the maximum value. So once again, let's recap what we just did here. Running this line brings up a file selection box. You navigate to the directory where your data file is and you select it. And this is the result of file.choose function, which is the first argument in the read table function. Alternatively, you can put the file name with full path in quotes as the first argument. So instead of file.choose here, you could put the complete path of the file. The second argument means that we are expecting to see column labels in the first row. So the first row in the CSV file is for column headers. And the third argument indicates how the columns are separated. In our case, it's a comma separated file, so that the columns are separated using commas. Once we have the data loaded in our data frame, next step is we are processing it. So in the second line, we select the data stored in the brain column, and we are using function summary to obtain the basic statistical characteristics of this data frame and break them. Now my question is, do these quantities look familiar to you? They should if you have used basic statistics, or if you have already done it using Python. If you are careful, if you remember what we did in our Python statistical analysis lecture, you would remember that these are the values which help us assess if our data is actually consistent. We need to look at the minimum value and the maximum value, which are the extreme values, to make sure we don't have outliers or a lot of extreme values in our data. Next, let's look into graphics and data visualization. One of the core benefits of R is its ability to produce data visualizations with very little effort. We could use R's inbuilt support as well as the numerous libraries or packages and functions which are available from the developers around the world. So let's explore this. So before working with graphics and plotting, we need to make sure that we have the appropriate libraries. You could open RStudio, you could go at the top, select Tools, Install Packages, and then a dialog box will pop up. Make sure that you type ggplot2 here. So this is the library which is responsible for all the visualizations in R. Make sure that the install dependencies is checked. Hit install and the ggplot2 package will be downloaded and installed in your computer. Next, we will load the data. For the examples in this section, we will work with the customer data regarding health insurance. So you can download the custdata.tsv file from inside the Wikit lectures folder. The TSV here stands for tab separated values, which means that instead of commas, the fields are separated using tabs. Therefore, our loading command will become a little different from what we used before. Once again, I'm copying the command. I'll call it tf customer data, and I'll provide complete path to that folder. So here I'm copying it and I'm pasting the complete path. My file is called custdata.tsv. Now this is very important. Note that we must change this separator. So previously the separator was comma, now it's a tab. You can also replace this file name with the file.choose function as we did previously. In that case, a file navigation box will pop up and you will be allowed to pick the data file from your computer. Let's execute this statements. Okay, now we have tf custdata. Similar to our steps in Python, we need to first import the libraries. And here it's done using the library function. This will import the ggplot2 library. Next, I am typing ggplot custdata plus geom. We are creating a histogram here, so we are doing a geom histogram. Our x-axis is the age. We are using a bin width of 5 and we are using blue as a fill color. Now this creates the histogram as you can see in the plots at the lower right corner of your screen. Similar functionalities were achieved using the Python matplotlib. But if you think beyond R and Python, very few programs or very few softwares have the capability of producing such a professional looking visualization. And that's why R and Python are extremely important, extremely useful for data analysis. Now, if you want to visualize your data frame, you could either type the complete data frame and just hit run, or you could just use a head function and type the data frame inside it to view the first few lines of the data frame. So head dfcustData produces the first 6 rows from the data frame. Now you can see the different columns which were there in the data frame. Let's now look at a field with categorical values, which means they are not continuous numerical values, but instead they have different categories. The data marital stat is like that. It contains 4 different values: divorced or separated, married, never married, and widowed. We'll use ggplot dfcustData, and this time we are creating a bar graph. So that's our geom bar. AES means we'll be using the frequency of our data as y-axis. This time we'll be filling it with the color orange. Let's execute this. Now you can see how our data looks. You can see once again on the lower right corner. There are of course many other charts one can draw, but we'll stop with this for now and look at some other things which we could do and plot with the data which we have. You remember correlation analysis. So let's try that here. We'll be using the core function and we'll use dfcustData and the age column, and we'll correlate it with the income column. So we are trying to find out if there is a correlation between age and income. This gives us a low correlation of 0.027. But just wait a minute. If you look at the data more carefully, you will understand that there are some null values, meaning that some of the ages and incomes are reported to be 0. That can't be true, and perhaps this is a reflection of missing values in our data. So let's redo the correlation again, and this time we are picking only the values which are non-zero. And here's how you can do it. We are creating a second version of the customer data, and this time we'll use the subset function. We are creating subset of the original data frame, but this time we have a condition. Our condition is when the value of the age is greater than 0 and the value of the income is also greater than 0. I'll also add when the value of the age is less than 100. So what I'm checking, I'm creating the new data frame from customer data using 3 conditions. The first condition is the age has to be greater than 0. The second condition is that the age has to be less than 100. And the third condition is that the income has to be greater than 0. So we extract all those instances or all those rows from our dfcustData to a new data frame, dfcustData2. Now we will do the correlation analysis as we did before. So I'm copying the code from there, but we will be using the new data frame. I'm running both these commands together. This time we got minus 0.022. That's still pretty low, but what you should note is that the sign of correlation has changed. As we move forward with other forms of data analysis, pay attention to the nature of the data. It's not always clean, it's not always right. So we have to be careful. Otherwise, we may end up with results that either don't make sense or the results which are completely wrong. So that's it for today's lecture. Thank you.